You can all see my whiteboard. They express this in this form, 2 marks. So he said the first thing is you check if the coefficient of x squared is 1. If it's not x squared, you divide by whatever. It was 3, I divide everything by 3 first. So now the coefficient of x squared is 1. So I simply look at the middle term. I divide by 2. The coefficient, which is 10 divided by 2, which is 5. So it's x plus 5 squared like this. Then I have to take away the square of that. So plus 14 minus 5 squared is what? 25. Like that. So that is x plus 5 squared. What is 14 minus 25? It's negative what? (14 minus 25), what do you get from your calculator? Should be negative 11. Clear? Makes sense? So this graph is a sketch. I'll explain how this works. I'll use this to sketch these transformations that are happening. So if it's negative, remember the graph of x squared is like this. I'll show you something. The graph of, this is the normal graph of y is equal to x squared. But now it's a plus 5. So it means if I say, if it's x is equal to 0, for example, when I have this, x is no longer 0, because now I'm saying 0 plus 5. You see this? I hope it's making sense. Eh? So when x is equal to 0, it's actually coming here. So this whole graph is being shifted, moved to this. So your 0, your turning point here, it's like this. That's the first thing that happens. Then when I say negative, I take this whole graph. If it was positive, I take it up. I take this from 0, the turning point, all the way to negative what? To negative 11 here. Like this. So my graph will be something like that. Clear now? So it's 2 transformations. 1, I move the graph 5 units to the left, the normal curve. Then I move it 11 units down. Clear now? You guys are quiet. Is that clear?
Yes, sir. Yes, sir.
Yes, sir.
Number 9, calculate the perimeter of the sector. So how do you calculate the perimeter of a sector? We talked about it. What's the formula, by the way? Who remembers? It's equal to what? Theta over 360 multiplied by what? Lilo? Perimeter of a sector. So it's the length of an arc multiplied by 2 pi r. You should always remember this. That's how I call it. This gives me the arc AB. But now, because the sector is perimeter, I need to add 2r. This distance plus that distance plus the length of the arc. This formula gives me the length of the arc. Clear now? Always remember this.
Yes, sir.
Don't confuse perimeter of an arc. If it's perimeter of an arc, is simply theta over 360 multiplied by 2 pi r. But this is a sector, so it has to include that plus that. So now this is 165 over 360 multiplied by 2. What is our radius? 8. Plus 2 times 8 is what? 16. So what do you get? Use your calculators.
So I'm getting 39.
Okay, wait. Let's wait for the others. Are you getting the same values? The rest? You said 39.038 something. So 39.
Yeah.
The area of the sphere is the same as the area of what? Of the sector.
The sector.
Area of the sector is given by theta over 60 multiplied by both. It's a fraction of a second multiplied by pi r squared. Are we together?
Yes, sir.
Now, it's equal to what? What is this? The surface area is equal to this. What is the surface area we are given there? It's 4 what? 4 pi r squared. Calculate the radius of the sphere. Now, you see, so let's plug in. We now know that this is 365 over 360 multiplied by pi multiplied by radius is 8 squared. And they're saying that is equal to 4 pi r squared. Yeah? Like this. Clear now? So it means I can divide both sides by pi. Then I have r squared is equal to 165 over 360 multiplied by 8 squared multiplied by pi, like from this, divided by what? By 4 pi. Pi cancels. Clear now?
Yes, sir.
So it simply means r is the square root. It's equal to 165 multiplied by 8 squared, 64, divided by 360 times 4 square root.
So I'm getting 4.1, 5.1, 5.42, sorry. Yeah.
What are the rest of the guys getting? They are quiet. Then they bring their calculators.
Wait, did you say times 4? Okay. By 64 over 4. Okay, sorry, I'm getting 2.71.
2.71. Okay, the rest are quiet. Lila, is that what you're
That's
getting?
what I got as well, sir.
Okay. Where is your friend, Dawn? She on holiday?
I'm
Now,
not sure, sir.
a cone is made by joining the sector. Okay, made from joining the sector. Okay, a cone is made from the sector by joining AO. Okay, AO to AB. Okay, calculate the radius of the cone. Is it from the same person? My cone is made from the sector by joining. Calculate the radius of the cone. So how do you do that? Let's go and check something. This is the circle. Oh, you see what they're talking about. Joining this one.
Yes, sir.
And that one is 8 centimeters. Huh? So they're saying joining this one and that. Let's see what they're talking about. So where is the B? It's a very funny shape. Okay, so this means OA remains the same distance. Huh? Are we agreeing?
Yes, sir.
8 centimeters. But what becomes the height? A cone is made by joining AO to OB. AO to OB. So AO to OB. We are joining these two. Okay. Okay, so we have the area of the sector, that angle. AO, I just need to set to OB. And they're saying calculate. What's the height? So this is the slant height. It means we need to
Yes, sir.
find H so that we use Pythagoras theory. So what do you do there, printers?
I'm not sure, sir.
AO, a cone is made by joining from the sector. By joining AO to OB. So what becomes the height then? Let's see how you guys figure out that.
Sir, aren't you supposed to use Pythagoras?
Yeah,
Like when you're trying to...
but how do you find the, yes, I agree, Pythagoras, that's what I said. But you use Pythagoras when you've got two sides. So which means we have to figure out what is the height.
What R is, right?
The height, remember this, we are going to use Pythagoras, I agree. But I'm saying
Yeah.
we are joining AO to OB to make a cone. I don't know whether it makes sense. To make it, sorry about this. So if we join them, we make a corner. So what will be the height?
Yes,
So isn't that the symmetry here if we were to join these lines here?
wouldn't, yeah, like the...
Because this one
That's
is
what-
joining this, huh?
Yes, sir. It would be sort of like the radius of that AOB shape.
What do you mean the radius?
I don't know, like I was thinking it would be the length of like cutting through that shape. I don't know if that makes sense.
Cutting through like what? Can you write on my pen what you're trying to suggest?
No, as in like any line from O to the line A, well, the curve AB.
You mean this line, the radius?
Yes, but like confirm the radius to any point on, I mean the center to any point on the curve is a radius, right?
Yes, it's radius.
So I'm saying, isn't that, yes, so from any point.
Yes.
So wouldn't the height be 8?
I get your point. You're saying because you're saying from the center to what? From the
To
center
any
out.
point on AB.
Okay.
Yes.
Okay.
I don't know if that's right, but
No.
that's my thinking.
Because this is the center. So as long as it's
Yes,
from
sir.
that to that. So if we,
It will be 8.
you're saying this will be 8 centimeters. But what will be this one? Maybe it's actually from what you said.
OA. Would it not be the same as on the diagram? Because
Yeah, but if you are saying that now, you are implying that this is an isosceles triangle. For which it can be an isosceles triangle. You are implying that because this is the longest side here. That's why it's a right angle
Okay.
triangle. Can you see that?
yes.
This is the longest side. Probably it's making sense to you.
It is. So how do we find H?
Yes, that's what I want to do. How do you find H?
H.
So we also know that this is what? 8 centimeters. I'm just trying to figure out some geometry. This is also a.
Oh, I see where you're going.
Okay, so saying this is 8 centimeters, 8 centimeters. This is 90 degrees. Yes, that's correct. So how do you find H then? The height? Everyone. What do you think?
Wouldn't oh no, sir. No, that's
Yes, what are you thinking? You had suggested something.
it would be like the
Because h is the perpendicular height. Like this. Maybe think of this shape because we are joining AO to OB to make a cone. AO and OB are on A, the same point A becomes the same point with B. Is that correct?
Okay, so please could you give us a clue and then we can work from there.
No, I gave you a clue. I said we are joining what? This one.
A to B,
that.
right?
So this A here is now also on the same point here.
Okay.
And they're saying when we are doing that, we are forming a cone.
And we're trying to find the height from the point O to the bottom of the cone, right? That's what we're doing.
Yes.
Just to confirm. Okay. But say, isn't it 8 though? Because if we fold the A onto B, right? Just imagine like that half thing, right? And then if we cut from O to the base, it would be 8. Because it's uniform throughout. It's not like we're like folding it over and over again. It's just one little fold thing. I don't know.
Okay, yeah, there. Now you got stuck. Ryan?
Yeah, I'm stuck there.
So I'm still trying to figure out.
Yes, I'm trying to figure out. What do we have here? We have a sector. Huh? Are we all agreeing? That from this sector, we found the area of the sector. But now we are using that same sector to make a 3D shape.
3-dimensional.
Or a 3-dimensional, which is a corner. So, but for a cone, we can't talk of area, we talk of volume. Huh? The volume of the cone. Does that make sense?
Yes.
So my question to you, isn't the volume of that cone the same as the area of the sector?
How though? Wait.
The area of the sector is all this. No, I'm just asking that. It's all this. Yes.
I don't think so.
But now we are from this, we are joining that so that we make a what? We make a cone.
A cone. But how would the area be equal to the volume?
No, I'm saying the volume of the cone. Because when we make the shape, we are making from the same shape or from the same material, we are making a cone. From a 3D shape. Because if it's a 2D shape like that, I can't talk of volume. I can only talk of area or area of the cone, which is what we found.
Yeah.
But now when we make, because we know that the volume of a cone, did they give you the formula? And if they don't give you the formula, Normally they give you. If they didn't give you, you should know the volume of the cone, by the way. So cone is made by joining this. Okay. Let's just check something here. The surface area of this sphere is same. The area of this sphere is same as area of the sector. Okay. How do you find volume of a cone? What's formula? Volume of a cone, how do you find it? How do we find volume of a cone?
Aren't they supposed to give us the formula?
Oh, what is given there? Anyway, let's talk of this first. The radius, before we jump to that. So how do you find that thing? Calculate the radius.
So can't we use this is just coming from the way, but can't we use the circumference of the circle? Because the circumference is the length of A to B, right?
No, the circumference is a base.
Mm-hmm.
Yes, the circle
What do you
of
mean?
the base.
Yes. This one?
From that, yes, that is basically AB.
You mean the circle?
Is it not?
You mean this circle?
Yes, for that circle. And then we use the circumference to find the radius.
We can do that. I thought someone was going to quickly think, because this is just a section of the what? Of the circle. That's what you're saying. Which is theta over whatever times pi r squared. That's the area of the sector. Yes.
Yes, but when you join AB, right, that makes the base of the cone, and then the circumference of that base, that circle, is the length of AB. So we need to find the length of AB to find the circumference, and then we can.
What are you saying, length of AB? You are confusing yourself. You have an idea, but you're almost there. What are you saying?
Okay, so when you join the cones, right? When you join the shape to make the cone, you're basically joining A to B, right?
Yes, and it becomes
with center O.
Yeah, and it becomes
then,
1 point.
Yes, it becomes 1 point. So basically what I'm saying is that circle at the bottom is AB. Like, it's from the sector, it's that length that's just been joined to make a circle instead of that little shape thing.
You're saying this circle here. Okay, I get your point. You're saying when we join this.
Yes, when we join it, it becomes a circle. That's the shape of it when we turn it into a cone, right? And then the length of AB is the circumference of the circle. Right? And then let me just write down the formula.
No, it's correct what you're saying. I get what your point. You're saying when we join, now we are agreeing
when we find when we find the circumference, we can find the radius. But let me just check what
I get your point, which is so when we are saying when we join these two, which is correct. Yeah? Yes, that's correct. So we say what? No, it's not. It's length of the arc there. This length of the arc becomes the circle at the bottom. Huh?
Yes, that's what I'm trying to say.
Which is, do we agree with Heather?
Yes, that's true.
It's true. Huh? So if it's true, it means theta over 360 multiplied by 2 pi r. That gives us this, the length of the arc here, is equal to pi, how define circumference of a circle, 2 pi r, but let's use a different, maybe let's say r1 like that. So now from this, we are simply saying 165, which is correct what you said, 360. That's what I wanted you to figure out. Multiply by 2, multiply by, what is the radius? 8 centimeters like this. Is equal to 2 pi r1 like that. Clear now? Then we can divide both sides by 2 pi r. So we have 165 over 360 multiplied by 2 pi multiplied by 8 is equal to r1 divided by 2 pi. This cancels like that. So what do you get?
I wasn't. Let me see.
So once if you fail to get that logic now, then it becomes difficult. That
Then
question.
basically you use your answer and put it into
What is the radius?
the formula. I didn't really.
So
Where's the workings?
No, we were doing the working there. I thought you saw that. We cancelled this.
3.67.
I wasn't.
So
Okay,
let's do 165
3.67.
times 8 divided by 360. The two cancels like this. What do you get? 3.67.
67.
Okay, is that clear with everyone there? Some are joining later. I hope they will get it, what we're explaining here. Brendan, does that make sense? Lila?
Yes, sir.
Okay. Otherwise, now that's fine. So now, basically, that's true what she has said there. Then now we can, it's now easy to calculate this, like what I'm saying, they give you the formula. Was now know the 3.67.
What?
Okay. So volume of a cone is 1/3 what? Pi multiplied by the radius that we got there, 3.67 squared, multiplied by what? Where is the catch? Is on the height. We don't know the height. What do you do now? We go back to this shape here. We're going to use Pythagoras. So we said the radius is 3.67. And we know that this is 8 centimeters. So how do I find h? This is 90 degrees. So h is equal to what? 8 squared
minus 3.6 squared.
3.67 squared, yes, like this.
Well, then
Square
like
root.
the square root of that.
So what do you get for the height?
You get 7.1.
Three significant figures.
7.111.
It's shown in the lesson there. What happened to you? I mean the other show. Oh, sorry. So then we are not done. We now know that's 7.11. So now we're now saying half third multiplied by pi multiplied by 3.67 squared multiplied by 7.11. 1/3 pi r squared h. Where is the other shown?
We get 100.28.
Yeah, you do. You get 100.28.
£100?
280.
Yeah, but 1, 2, 3. So it's as good as 100. To
At
three
0.3.
significant figures.
100. Yeah.
To three significant. Now a rhombus has got that diagonal. A rhombus has got a rhombus ABCD has got a diagonal AC, where point A is this and point C is this. Calculate the length of that. So what do you do?
You draw it.
So you draw it, huh?
Yes.
Okay, wait a moment. Just need to reply. So you can draw it a rhombus any way you want it. It's more like a diamond shape, okay? So we have A, B, C, D, yeah? Making sense? And what you want to calculate is the length of what? Of A
AC.
or AC. But it's not even necessary. Are we given the A and are we given the C?
Yes.
Yes, so it's not even necessary. It's distance between 2 points. How define distance between 2 points? What formula?
Be like
Yes.
minus them.
AC is equal to what formula? We should know that. X1 minus X2 squared
Over.
plus Y1 minus Y2 squared square root.
Yes, sir.
That's how we find it. So you pick any value there. If you want to pick 4, it's fine. So it's 4 minus 3 like this, squared, plus, I pick the Y value there, negative 4 minus 10 like this, squared. That's all I'm doing, like this. This gives me 7 squared. This gives me 14 squared. Negative 14 squared is the same as 14 squared, like this.
$15.2.
That clear, everyone?
Is it not 15.7?
Yeah.
Can we punch? Can we check? How did you get 15.2?
It's 15.7.
14 squared plus 7 squared.
Oh, yes, sir.
Get
Yes.
245. Square root of 245 is 15.7.
7.
Rounded to 3 significant figures. Show that the equation of AC, we talked about it, equation between 2 points. So what you want is y is equal to mx plus c. So what you want is the gradient first. Change. So m is equal change in y. So I can say 10 minus 4 over negative 3 minus what? Minus 4. On top, what do I get? 14.
14.
Divided by minus 7. If you use your calculator,
Yes.
then you get minus 2. So it means y is equal to minus 2x plus c.
X plus C.
Then you can use the method maybe that you have been taught at school so that I don't confuse you. You can use n of the points. So if I use 4 negative 4, 4 minus 4, I'm saying when y is negative 4, x is 4. So I'm saying 2 brackets 4 plus c. So negative 4 is equal to 8 plus c. Take this the other side. It's minus 4 minus 8 is equal to c. So c is equal to minus 12. That clear?
Yes, sir.
What? We have a plus 4. Did I make a mistake there? What's the point? 4 negative 4. Oh, you left me. This is a minus 2 here. Okay, it's fine. Let's just correct it. So everything was correct except that we forgot that this is a negative. So y is negative 4 minus 2 multiplied by 4 plus c. So this is minus 4 is equal to minus 8 plus c. Take this the other side. So y is equal to minus 4 plus 8, which is equal to 4. Clear now? So y is equal to negative 2x plus 4. Even if you had picked this point, I'll prove to you there. Y is equal to minus 2x plus c. Let's use that. When y is 10, this will be minus 2 brackets negative 3 plus c. 10 is equal to negative, positive. Take the 6 the other side. You see, still get the same answer. Clear now?
Yes, sir.
Find the equation of the line BD. BD. Now you have to think BD is like this. So what do you know about a rhombus? Properties of a rhombus now. We now know the equation of the line AC. What do you know about this line? It bisects at what? Diagonals of a rhombus bisect at 90 degrees. Huh? Bisect at 90 degrees. And this diagonal is bisected. So this is a midpoint of AC. Huh? So you see, that's why it's 4 marks. So we now know that the first thing is that we remember AC has got the equation y is equal to minus 2x plus c. But now for BD is perpendicular. Perpendicular to AC. So if it's perpendicular, it means its gradient of that is the negative reciprocal of this. So minus brackets minus 1 over 2 or 2 over minus is just the same. So it's a positive half here. It's the gradient. So it means that the equation that we want is equal to y is equal to half x plus c. But we don't even know any point. But we can find the midpoint where it's bisecting this line into 2. So what's the midpoint of AC? Midpoint of AC. What remembers midpoint x1 plus x2.
3 over 2.
We're saying this plus that over 2. Minus 3 plus 4 over 2. Then the y value 10 plus minus 4 over 2. So what do you get for midpoint? There we get half. There we get, if we add this, we get 6 divided by 2 is what? 3.
3.
So that's the midpoint. It's a point on this line here. So then I substitute to find C. So when y is 3, this is equal to half multiplied by what is the value of x? Half plus C. Now 3 is equal to, what is half times half? A quarter plus C. Take the half the other side. C will be equal to 3 minus half. Clear? What is 3 minus half? Is 2 and what? 3 minus a quarter, sorry. You guys are quiet. We're taking a quarter this side. 3 minus a quarter is 2
and 3 quarters.
Is 2 and 3 quarters. What is 2 and 3 quarters as an improper fraction?
11 over 4.
11 over 4. So we are done. Y is equal to half x plus 11 over 4. Clear now?
Yes, sir.
And you get all the 4 marks. Wait a moment. Just wind up this. Oh, some are going back to boarding schools. Okay. Some will still be with you. What? A level? Sorry about that. O level. Not A level. There. You see, they love these questions. They're now bringing differentiation since March. A curve has got this. find the coordinates of the turning point. It's like that every year when they introduce something, they always bring it. So definitely you're going to get a question like, so a turning point, dy over dx is equal to 0. Gradient, so let's calculate the gradient. 3, reduce this by 1, x squared. Multiply by 2, 16. Reduce this by 1, x. Then we said differentiation of x is always 1, so it's plus 5 there. So it means 3x squared plus 15x plus 5 is equal to 0. Let's see if we can factorize it first. Looks like it can be factorized. So 5, it can be factorized. Plus 5 plus 1 is equal to 0, which means 3x plus 1 equal to 0, or x plus 5 is equal to 0. So it means x is equal to minus a third straight away. Take the 5 the other side, or minus 5 like this. So I now know one of is minus a third. I now know the other one is minus what? Minus 5. Then I use my equation, which is y is equal to x cubed plus 8x squared plus 5x, I think, yes. I now use that to substitute, to now say when x is equal to this, what will be this value? When x is equal to that, so let's substitute. You can use your calculators. So it's minus a third cubed, that's what it means, plus 8 brackets, negative 1 over 3 squared, use your calculators, plus 5 brackets, minus a third. What does your calculator give you? Here's a fraction. What did what do you get? Every calculator should be able to do that.
Negative 0.81.
I said there's a fraction.
Yes, sir.
Did you give me a fraction or a decimal? Negative 22 over what? Over 7. There's a fraction. I said if you do your calculator using a over b, you get that same fraction there. A over b, and just remember the negatives, they're cubed there. Plus 8, even a sharp, I'm also using an old sharp calculator, they gave me this answer straight away. Then let's plug in 5. So it will be negative 5 cubed plus 8 brackets negative 5 squared plus 5 brackets negative 5. What do you get? That one either? Yeah, now quiet. Sorry, princess. We get a value.
Yes, sir.
50. They're simply using a calculator. Plug in.
What I'm getting here. Okay.
I use no. Remember brackets, negative 1. Use a over b on your calculator cubed like this. Plus 8 brackets, negative that you're using a squared, plus 5 there. Even this, if you use your brackets, you get the same answer. Right?
Okay. Let me try again. I forgot to put in brackets somewhere.
No, if you don't put in brackets, it won't work.
I got 50, yeah.
Determine the nature of these two stationary points. We said we find the second derivative. We now know that the first derivative, dy over dx, is equal to 3x squared plus 16x plus 5. Plus 5. Let's go to the second derivative. I'm differentiating this again. So this is 6x. This is simply plus 60. Done. Then I use my values here. So when x is equal to negative a third, this is 6 brackets, negative a third plus 60. What do we get?
We get 4.
16, sorry, not 6.
Oh, psych. We get 20.
20? How did that
Am
do?
I wrong? Let me
No.
try it again. Minus 32.
No, this is 6 brackets minus 1
Yeah,
over 3.
oh, so do you always have to put brackets? Like, it's just
Yes,
an
you have to put
unnecessary
brackets.
save.
That's why
Okay.
you're getting funny answers.
Okay, final answer 14.
Simply 14 was minus a third of this is minus 2. So 14, so d, it means d squared dy, second derivative is greater than what? 0. So what it means is this point here that we're talking about, which is minus a third, and if it's greater, it means a third negative 22 over 7. This is a what? If it's greater than 0, it's a local minimum. It's a local minimum. Local minima. Now let's calculate the other one when it's what? It's negative 5. So let's use negative 5. So d squared y over dx is equal to 6 brackets negative 5 plus 16. We get a negative value, huh? Which is a local.
You get negative 14.
Yes, so it's a local maxima.
Yes.
Maximum. Clear now?
Yes, sir.
Yes, sir.
Okay. What's the next lesson?
Physics, like later on.
Not chemistry.
Chemistry, sir.
I'm not sure.
It's chemistry.
Wait, what time is
I
physics?
have physics
Physics
later
is
on.
at 2 p.m. So let's switch on to chemistry just now. No break.
Okay. Bye, sir. See you in physics.